Hello everyone, today we are going to be solving the Cameroon GCE paper 3. Okay, that's pure maths with statistics paper 3 of June 2023. Now let's meet the first question. Our first question says that two events A and B are such that probability of A happening is 2 on 3, the probability of A union B happening is 3 on 4, and the probability of A intersection B happening is 5 on 12. Find the probability that B happens. Okay, so question 1, we have been asked to find the probability. Question 1, they're asking us to find the probability of B. Okay, now in order for us to find the probability of B, we know that in order for us to find the probability of B, we all know that we can use the formula for the probability of union of events. Okay, that's the formula for the probability of union of events is that P of A union B, that's when we have the events A and B, is equal to the probability of A plus the probability of B minus probability of A intersection B. Okay, so what we have to do now is, you know that, do we have A union B? Yes, we have A union B. Do we have A union B? Yes, we have A union B, and A union B is 3 on 4. Do we have probability of A? Yes, probability of A is 2 on 3. Do we have the probability of A intersection B? Yes, and it's 5 on 12. So we'll just substitute this value, so we know that A union B is 3 on 4. 3 on 4. Probability of A is 2 on 3. 2 on 3 plus probability of B minus the probability of A intersection B. And what's A intersection B? That's 5 on 12. That's 5 on 12. So this is going to give us, making the probability of B subject to formula, it's going to give us 3 on 4 minus 2 on 3 plus 5 on 12. And the answer, when you simplify this, our answer is going to be 1 on 2. Okay, so probability of B is 1 on 2. Let me write it well. Probability of B is going to be 1 on 2. Underline. Okay, and then for question B has asked us to calculate the probability of A on B. That's the probability that event B is happening given that event A has already occurred. So that's the probability that B is happening after A. So to solve for B, we're going to have probability of A happening before B is given by probability of A intersection B. Okay, this is the formula, divided by all of this, divided by probability of B. Don't forget, whatever happens after is on the denominator. Okay, and this is the A intersection B in the question is 5 on 12. We have A intersection B, and what's our answer for B? Our probability of B is 1 on 2. So 5 on 12 divided by 1 on 2 is going to give us 5 on 6. So for B, our answer is 5 on 6. And then we'll do for C. Now what is C asking us? C is asking us to find the probability of B intersection A complement. Okay, don't forget the probability of B intersection A complement. And for B intersection A complement, that's the probability of B intersection A complement. For B intersection A complement, we know that A complement, okay, what is A complement? Our A complement, that's our A complement has not been given. So the probability of A complement is the same as the probability of 1 minus probability of A. Okay. So what do we have now? We have, and what is 1 minus probability of A? What's 1 minus probability of A? So our probability of A is 2 on 3. 2 on 3. So 1 minus 2 on 3 is going to give us, but we all know that probability of A complement is equal to 1 minus the probability of A. And how many events do we have here? We have 2 events, that's B and A. So if we remove A, we are remaining only with the event B. So 1 minus the probability of A will give you the probability of B. Okay, so it means that our probability of B intersection A complement is going to be the probability of B minus the probability of A intersection B. Okay, because A complement is B. A complement is B since there are only 2 events. So if you remove A, that's no A, the complement of A is B. Okay, so right now we're going to have probability of B is going to be calculated. This was 1 on 2 minus probability of A intersection B. A intersection B is 5 on 12. So here we have 5 on 12, and this will give us 1 on 12. Okay, so your answer to C is 1 on 12. Then for option 2, okay, option 2, well, given that a manufacturer of phones employs an inspector to check the qualities of his products. After testing a large sample from consignment, the inspector finds out that 2 out of every 10 phones are defective. A customer buys 2 of the phones, okay? Calculate the probability that both phones are defective. Exactly 1 phone is defective. Okay, so that total of that is a company that makes phones, and after testing, if you select 10 phones, 2 will always be defective. So calculate the probability that if a customer comes and buys, he will buy 2 defective phones or he will buy only 1 defective phone. Okay, let's draw the probability tree here. So probability tree here is going to be, so we have 2 out of every 10 phones. So 2 out of 10 phones, 2 out of 10 phones are defective, and then the rest is not defective. So that's 10 minus 2 is 8. 8 out of 10 is not defective. Okay, so that's the first draw. On the first draw, probability I will select a defective phone is 2 on 10. Probability I will select a non-defective phone is 8 on 10. On the second draw, okay, on the second draw, probability that will select a defective phone is going to be 2 on 10. And I'll tell you why it's 2 on 10, because most of you people will think that it's 1 on 9. I'll tell you why it's 2 on 10, because these are independent events, okay? These are independent events. It means that the second draw is the same as the first draw because the phones are chosen independently. That means that the customer does not know what is inside the bag. Okay, he does not know what is inside the bag and does not remember the previous phone that he picked. Does not remember it was defective or it was not defective. Okay, hence the selection of one phone does not influence the selection of the next phone. So the selection of the next phone will still be 2 on 10 because these 2 events are independent events. Okay, that's for it to be defective. And for non-defective, we have 8 on 10. Don't forget this 2 on 10 here. This is 2. And then if you selected a non-defective phone, probability I select a defective phone will be 2 on 10. Okay, and probability I select a non-defective phone will still be 8 on 10. Why are the values the same? Because they are independent events. Okay, who don't remember what we picked previously. before we are selected. There's no condition that have told us that given that the first has been effective. No, they are independent events. So to calculate this, that's our D. They have asked us that the probability that the both phones are defective. Okay, now the probability that this both phones, the probability that the first draw at the effective phone is 2 on 10 times. Okay, and our second draw at a defective phone will be 2 on 10. So 2 on 10 times 2 on 10 is going to be 4 on 10. Okay, that's the probability that both phones are defective. That's D and D. This is D complement. That's D and D. D and D is 2 on 10. Okay, and the next one is that the probability that exactly one phone is defective. Probability that exactly one phone is defective. Okay, and this is given by, that's we have to consider the probability that on our first draw we had a defective phone. Okay, and then non-effective phone, because only one phone is defective. So on our first draw, our first phone was defective, plus the probability that on our first draw is our second phone that was defective. So the first will be non-defective and the second is defective. Okay, that's the probability that only one is defective. Here only one is defective, and here only one is defective. So we have to add these two probabilities. We are going to have, that's back to our tree, we have defective and non-defective. That's 2 on 10 times 8 on 10. 2 on 10